Remember last time we looked at logarithms, the main thing that I want you to remember is when we're solving a logarithm, what in general are we looking for? Like which part of the problem are we searching for when you're asked to find a logarithm? The exponent, okay? So I'm going to write this down again even though we wrote it down last time, but the answer to a log expression is the exponent. I mean, there's a little bit more to it than that, but if you can remember this, then I think you can remember what you need to know to be able to solve some of these. So let's go ahead and look at a few examples. So I'm going to give you kind of some varied, quick examples that I would want you to be able to show me how you can do them without a calculator. All right, so first let's look at this one. The log base 3 of x equals 2. Okay. I'm exaggerating the sizes, but make sure you're writing like the log, the x, and the 2 as a normal size thing, and then the base 3 is tiny, like an exponent size thing. Okay, so anytime you have a logarithmic equation like this to solve, the best thing that I can tell you is go ahead and rewrite it as soon as you can, because we're typically more comfortable with exponents than we are with logarithms. Okay, so you just need to remember what goes where, and I think one of them you get for free. Okay, the base of the log becomes the base of the exponent. Okay, and then what did we just write with a star next to it? The answer to a log is always the what part? The exponent, right? So it's 3 to the 2 power equals the other thing, kind of by default. The other thing becomes the answer to the exponential. So what is x then? 9? All right, but what if I move the unknown thing around? So log base 7 of 49 equals y. So again, we're not going to leave it like this. We're going to do what? We're going to rewrite it. Okay, so how would I rewrite it? 7 to the y power, right? This becomes the base. The answer to a log is always the exponent, and that needs to equal the other number by default. Okay, so what is the power of 7? Not the multiple of 7, but what is the power of 7 that would give us 49? 2. Okay, because 7 squared is 49, right? So what about this one? So that's a base b, not a 6, if you're wondering. So the log base b of 10 to the negative 4 equals negative 4. In other words, this time I'm asking you to find what the base would need to be. So we're going to rewrite it as what? Y'all tell me what would go where. The base becomes the what? The base stays the base, right? Where does the negative 4 go? In the exponent. Notice I do them out of order, but I'm doing them in order over here. So I always do base to this power equals this. Okay. And then honestly, this is kind of a goofy question, right? What to the negative 4th power would equal 10 to the negative 4th power? So what would b have to be so that they would match? Yeah, b is just 10. Okay. By the way, I wouldn't have been able to really use my calculator much on most of these unless I knew already the answer to part C. Why do I say I wouldn't be able to use my calculator? What did I tell y'all last week? What is the calculator log understood to be? Base 10, right? So for base 3 on part A and for base 7 on part B, that wouldn't have been so helpful. Although you can learn how to change the modes, I would just much rather you understand how exponents work instead. So what about this one? We get kind of an unusual answer. In other words, an unusual exponent. Okay, but if you just rewrite everything where it goes, and then we'll think about what it means to have an unusual exponent like we're going to have. So it's 25 to the what? 1/2 power equals x. Okay, but hopefully you remember that to the 1/2 power actually means what? square root. So you are going to need to remember that. We talked about it last week. Fractional powers mean roots. Negative powers mean fractions. And then, of course, once we know it's square root, that's easy to find, right? So what is x? 5. X is 5. All right, so let's do one more. So the log base 5 of 1 over 125 equals x. So once again, we're going to get it out of log form as soon as we can. We're going to think of it like an exponent. So it is 5 to the what power gives me 1 over 125? So the fact that I have a fraction should automatically in your mind make you realize you have a certain kind of number as an exponent. So I just mentioned it, but what kind of exponents give us fractions? Negatives, right? So now I just need to find like how many 5s multiplied by themselves give us 125, right? 5 times 5 is 25, times a third 5 is 125. So instead of 3, it'll actually be what then? Negative 3. Okay, so no matter where your unknown quantity is, even if it asks you something like this, okay, if it says to evaluate this log, then what you're trying to find is the answer. So if it just says, for instance, let me show you what I mean by that. If it just says evaluate log base 3 of 27. Okay, well then what it's really asking you to find is the answer, right? It's saying like, what's the answer to that? Okay, and we did some of these last time actually. So then we would just do a rewrite step. And this is where we would use kind of our question marks, right? So our base is 3. I want to know what exponent I need to give me what? 27. Okay, so how many 3s do I need to give me 27? 3 times 3 is 9. 3 times 3 times 3 times 3, right? 3 of them would be 27. So the answer is 3. Okay, so I want to be clear about what I'm looking for here. Like, only this is the answer, but this is your justification as to why, if that makes sense. So like this is like your work, but the answer is just plain old 3. Okay.
So it's not going to be an x or like x equals 3 or anything like that. It's just.
Well, I mean, on this one, no, because it just said evaluate. Okay, but I just as easily could have made this equal to x, and then you would have said x equals 3. You see what I'm saying? So it just matters on kind of how it's worded. But on like my math lab, for instance, when you're doing your homework, you won't type in this full thing. This is just your justification for why the answer is 3. Okay, so you're looking for the exponent, and the exponent is the only part of the answer that we're really looking for if it's just an answer. So consider that rewrite step to kind of be your work off to the side. Okay. So let's do some that might be a little tougher, like maybe we have to use some of our exponent rules or our log rules. So I want you to write this one down, and we're just going to break it down into baby steps. All of those bases are b's. So it's all log base b's. Okay. So I'm going to give you a hint here because we've had, a few class days or a few days where we haven't been in class. So you need to use your log rules here. In other words, if you have something really, really long and drawn out, then we're going to try to use our log rules to simplify. Okay, what were our 3 log rules? Product rule was one of them. What was the other 2? Power rule and also quotient rule, right? Those 3 rules. So the first rule we're going to look at is the power rule, because what does the power rule say I can do with those numbers in front? I can write them in the exponent spot, right? So this is the same as the log base b of 8 to the 2/3 power. And this is the same as log base b of 9 to the 1/2 power. And then notice nothing happens with this log base b of 6. Okay, so the rule I used here was power rule. But now I think I can simplify these. Okay, because these are just going to be number type answers. Okay, so I can use my calculator, but I'd really, really like you to not need to use your calculator. For instance, what is 9 to the 1/2 power, and how come you know that? It is 3, so how do we know it's 3? Because what does 1/2 power mean? Square root, right? So I'm going to start with that middle guy, right? So this is just log base b of 3. This is going to stay log base b of 6. Okay, so let's talk about this one. This one's a little tougher, right? What would it be if it were 8 to the 1/3 power? That would mean what kind of root? Cube root, right? What's the cube root of 8? 2, but then we're also going to do what because of the 2/3? We're going to square it. So this is actually equal to 4. 2 squared or 4. By the way, on the left-hand side, we're not doing anything, so I'm just going to carry down that step every time. All right, so we're going to do some more stuff, but I just want to remind you that you can also use your calculator if you just really, really must. Okay, you could have done 8 raised to the 2/3 power. Just know that if you have an older calculator that doesn't open up a little exponent box like mine just did, you'll need to use parentheses around the exponent to say, hey, I want 2/3, the whole 2/3 to be my exponent, not just the 2. So if you have like an 83 or under calculator, then you're going to need to do this. I don't really need to because of the way my calculator lets me punch this in, but you would need to do something like that if you had an older calculator. Okay, so just kind of a heads up there. All right, so now what can I do? Notice I have a plus sign here, right? So what rule is that implying that I'm going to be using? Product rule uses addition, right? But then I have a minus sign here, and what rule does that imply I'll be using? Quotient rule here. So let's just see if I can do this, and you can actually kind of do it in one fell swoop. We're going to have log base b. Okay, so what are we going to do between 4 and 3? We're using product rule, so we're going to do what with them? We're going to multiply them, 4 times 3. But then when we get to this one, we subtract it, so where do we need to make that one end up? As a divided by, right? So maybe like divided by 6. Okay, or you can write a whole big line. So let's talk about what that would be, and then let's talk about maybe a quicker way we could do it. So this is going to be the log base b of what? What is 4 times 3 divided by 6? 2. By the way, this left-hand side has not changed. Okay, so one way to think of it is, where do negative exponents go when we simplify things? Where do things that are negative exponents go? We don't leave them on top. To be proper form, where do we kind of send them? We send them to the bottom, right? And essentially that's all we're saying, okay? Remember how I said the log is an exponent, right? So it's just a negative exponent and it's being sent to the bottom. Notice these two positive exponents are staying where? Staying on top, okay? So that's essentially what you can kind of think about when you solve these. So this is basically what I have left now. The log base b of x equals the log base b of 2. So then what must x have been so that the left and right sides match? So x is 2. So that was a lot more convoluted to get to that answer, right? So I just had to use all of my rules actually, okay? So you need to make sure that you go back and review all of these rules, okay? All your power rule, product rule, quotient rule, rules of logarithms, okay? Don't forget that those are also the same names for the laws of exponents, okay? So they work much the same way because logs are just fancy what anyway? They're just fancy exponents, that's all they are, okay? Okay, so we're going to look at some other problems involving logs, but before we do, I want to go over a rule that I want you to memorize, but I'm also going to show you why it's true. You can't take the log of any negative number or 0, okay? So you can't take the logarithm of any negative number or 0. In fact, when you do, you're going to get an error. So let me show you an example of one, but then we're going to talk about why it works out that way. So if I try to do the log of -10, notice it's going to give me error, non-real answer. Okay, and if you try to go to the error, which by the way, if you're using your calculators, you should try that every once in a while. Like the go to button tries to tell you kind of where the problem is. Notice my cursor is just at the end because it's kind of confused. Sometimes the cursor will be over the negative sign itself, but it'll try to kind of say, hey, what's the problem? But if you had a bunch of different stuff, it would highlight just the log of the negative thing. Like for instance, if you had log of -10 plus log of 100, it's going to give you an error, but then when you say go to, it's going to put the cursor there like here's your problem, not with the other log, it's with the first log. It tries to kind of tell you where the problem is. But anyway, let's talk about why you can't do it. Okay, so let's take the one I just punched in the calculator. If I tried to solve the log of -10, okay, so let's do what I was doing with all the rest of them. Let's try to rewrite them, or rewrite it. Okay, so from last week, what did I say the understood base was if you're not given one? For log anyway. When it's ln, what's the understood base? E, right? But when it's log log, the understood base is 10. So what question you're trying to answer is, what power could I raise 10 to that would give me -10? Okay, and what do you notice is a problem with that? This is not possible, right? There's no power of 10 that would ever give me a negative number or 0 for that matter, okay? Because what does 0 as an exponent actually give me for an answer? Not 0, but what? 1, okay? And in fact, even a negative exponent doesn't give me a negative answer. A negative exponent gives me a what kind of thing? A fraction, right? So there's no way that this ever would work, okay? So in other words, this can't happen. 10 to the something power would never ever be -10. So anytime you will be taking the log of a negative or 0, you're just going to have to say no solution or it's not possible. All right, so keep that in mind as we use our log rules to solve some other problems. So let's say that I asked you to find x in the following problem. Log of x minus 1 minus the log of x plus 1 equals 1. So just a couple of things. What's the understood base? 10. Okay. I'd like to kind of do a rewrite step here, but I can't really do that because I've got 2 logs. Okay. But maybe I have a way to make this simpler. Okay, so what does this minus sign indicate that we need to use? Quotient rule. So maybe I can get together a nicer logarithm using quotient rule. So on the left side, I'm going to get the log of the first thing divided by the second thing according to quotient rule. Notice the right-hand side doesn't change. But now I can do a rewrite step. Now that I have it down to a single log, that's where the power of the logarithm rules comes in. Just make sure you're careful on the rewrite step, right? What would be the understood base again? I already mentioned it. 10, right? So it's 10 to the what power? So the answer to a log is always the exponent spot, right? So it's like 10 to the first equals x minus 1 over x plus 1. So it's base to the answer power equals the other thing, always. All right, so let's go ahead and rewrite this. Think of this like 10 over 1 equals x minus 1 times x plus 1. Okay, because when you do that, what can you actually do here? Anytime you have a fraction equal to a fraction in algebra, what are you allowed to do? That's your clue. You're allowed to cross multiply. So if you weren't sure about that, that's just anytime you have one fraction equal to the other, you're allowed to cross multiply and set those products equal to each other. So in other words, this is what you're going to get. You're going to get 10 times the x plus 1 denominator equals 1 times the x minus 1 numerator. So notice I literally cross multiplied, right, and set them equal to each other. So let's see if we can clean this up. So we'll distributive property here. Notice the 1 doesn't do anything to the right-hand side, but the left-hand side is going to be 10x plus 10 equals x minus 1. So now what? If I want to solve for x, I just need to get it all by itself, right? So I'm going to subtract x from both sides. I'm going to move the 10 over to the other side. And then I'm out of room, so I'm going to go up here. So 10x take away x is 9x. Negative 1 minus 10 is negative 11. So I end up dividing by 9 here. So I get x equals negative 11 ninths. But when I go to actually to actually plug it in, so I'm going to say check by plugging it in. In other words, with logs, we have to be careful that we don't have an invalid answer of some sort. So do you notice that we're going to come into a problem when we try to plug it in? What kind of logs are we going to be taking? We're going to be taking the log of a what kind of thing that we're not allowed to do? Of a negative, right? So notice we can't know logs of negatives. Just going to make that short. Which means actually this answer is invalid. So then what's the conclusion if the only answer we thought was the right one is not valid anymore? No solution. There's nothing that works. Okay? So if you get an answer that is invalid, we just say there's no solution at all. Okay? It's a little tricky, but just know that it's not invalid just because it's negative. It's invalid because you'd be taking the log of a negative. In other words, there might be some times where you plug the negative back in and there's no problem at all because you're not taking the log of a negative. Okay, we'll run into that here in a minute and I'll show you what I mean with a real example. So actually plug it back in to verify, hey, this isn't going to work. All right, so let's do another one. These are probably the most difficult of this section, but they're really the most heavily algebraic problems. So I really do want you to be able to understand what we're doing here. We're really just trying to baby step simplify as we go. Take a log that's maybe ugly, make it nicer, but then essentially we're always going to try to get it out of log form altogether. All right, so this time I have log base 3 of x plus log base 3 of x plus 2 equals 1. By the way, if you ever run into a problem where the bases aren't the same, you can do nothing. Okay, these rules only work when the bases are the same. Okay, so keep that in mind. So the last problem we used quotient rule, but what rule will we need to use in this problem because of that plus sign? Yeah, we're going to need to use product rule. Okay, which just says we're allowed to combine logs into a single log when we're adding as long as we multiply those two things together. And notice you do need parentheses there, like it is x times the whole x plus 2. So now I'm going to use my algebra skills and distributive property that. So it's going to be log base 3 of x squared plus 2x equals 1. So notice now we're at the stage where we can rewrite it. I'm putting a star by this rule because it is probably the most important rule. You're trying to get to the point where you can do a rewrite step. Again, because we don't prefer logs, we prefer to look at exponents instead. So how would I rewrite it? I'll start you off with the easy part. It's 3 to the what? To the first power equals the other thing, right? The x squared plus 2x. So notice, like, now I don't have any logs, right? So I just need to actually see how I can factor or solve an x squared equation. And remember, I do that. We did that this semester already by setting the equation to 0. So I've got 0 equals x squared plus 2x minus 3. and then I either need to try to factor or quadratic formula, okay, almost. I can pretty much assure you that all of these in this section are going to factor, so you don't have to use the quadratic formula, but you could. Okay, so remember we use AC method. However, I don't think we need AC method here. Why not? When the numbers in front of x squared is what? Maybe we don't need full-blown AC method when it's 1, right? So we're just looking for factors of -3 that add up to 2. There's only 2 factors of -3, right? It's either 1 and -3, or it's what? It's -1 and +3, right? That's the only option. So which pair is going to work and add up to 2 like we want? It's going to have to be +3 and what? -1? Okay. So we end up setting x plus 3 to 0 and x minus 1 to 0. So it looks like we get 2 answers, but we need to evaluate them. Okay. We need to make sure that we plug in and check these, because we already know we can't take logs of a whole big group of numbers, right? So notice if you try to plug it back in, you're going to be taking the log of a -3, right, which is not allowed. Okay, so what do we say about -3 then? It's invalid. Okay, notice taking the log of 1 is no problem, right? It's just taking the log of a positive, so we're good to go there. So it looked like there was only, or there was 2 answers, but in the end there's only 1. On test 2, I would want to see that you got both answers and that you threw one of them out. Like, I would want to see that you went through that factoring process and knew that there should have been 2 answers, but in the end only one made sense for the problem. Okay, so let's do one more like that, and then we'll move on to something else. So again, I want you to find x in the following problem. I don't really have any preference for base 3. It just so happens that the last 2 problems were both base 3. Okay, so because of this plus sign, what rule do I need to use first? Product rule. So when I combine those, I'm not going to change the base. It's going to be log base 3. But I'm going to have to do x plus 6 times x plus 4. Notice I used a bracket because I already had so many parentheses already. So notice here I can do what 4-letter process? FOIL. So I'm not even ready to do the rewrite step until I get this cleaned up. Okay, so this would be the log base 3 of x times x is x squared. X times 4 is 4x, plus 6x would be 10x total. And then 6 times 4 is 24. Notice everything else stayed the same in that step. I just FOILed out the x plus 6 times x plus 4. But now I'm ready to do arguably the most important step here, which is what? Rewrite. Okay, this is a very forgotten rule sometimes, especially on problems like this. Okay? In other words, a lot of students will just try to go ahead and factor this. Okay, but before we move on, why is it very fruitless to factor this? We already had that factored right here, right? So that's like just going in circles, right? That's not getting us anywhere. Because that's actually not what we need to factor. We need to factor what we rewrite here, which looks like what? 3 to the first power equals x squared plus 10x plus 24. Because I'm actually not ready to factor until it's equal to what? 0. So I need to subtract 3 from both sides. So what I'm actually factoring in the end is x squared plus 10x plus 21. So again, I don't think I need AC method. I can just ask myself, what are the factors of 21 that add up to 10? That should be pretty quick for us, right? What are the factors of 21 that give us 10 when we add them? 3 and 7, right? So I get x plus 3, x plus 7. So I'm going to give myself some room. So I end up getting x plus 3 equals 0, and also x plus 7 equals 0. So I get x equals negative 3 and x equals negative 7. Okay. Before you say, hey, both of these are out, I'm just going to go ahead and let you know that one of them is fine. So it's not the fact, I said this before, and here's the example where I'm going to show you why. It's not the fact that these are negative that throws them out. It's the fact that when you plug them in, you'd be taking the log of a negative. Okay, so let's talk about the difference between these two. Notice, when you plug in negative 3, is there actually a problem with plugging in negative 3? You're going to get a positive log here, and you're going to get a positive log here. Okay, so actually this one's okay. There's no problem with this one. So it's not necessarily negative numbers that get thrown out. It's when they get plugged in, the fact that they're negative. Okay, notice negative 3 would not be negative once you plugged it back in, right? You get a 3 here, and you get a positive 1 here, so no problem. Okay, but negative 7 is a problem. How come? When you plug negative 7 into this guy, for instance, what do you get? You get negative 1, right? So this one is invalid because you can't, again, take logs of negatives. It can be 2 answers that both work, and it can be 2 answers that don't work. Okay, and if it was 2 answers that don't work, then what would you say about the conclusion? No solution. Okay, but pretty often it's one works and one doesn't. I would say 95% of the time that's how it's just going to fall. But yes, theoretically, you definitely can have 2 that work and are fine, or both don't work and you have a no solution situation. Okay. Okay, so notice this stuff is like combining x squared stuff too, right? So it's really testing, do you know how to rewrite logarithms? And then also, do you remember how to factor, which was something that was on your competency test, something we've covered in the quadratic functions section. So you just aren't going to be able to get away from factoring. Okay, so if that's still shaky for you, then you need to really, really work on that on your own. Go to some tutoring for that or something of that nature, because factoring's here to stay. Okay, so the last type of problem I want to look at is kind of a flashback from our exponential functions section. So how do I solve 5 to the x power equals 66? Okay, so I want you to make a couple notes. Note that you can't write 66 as a power of 5. You can't do it easily anyway. Okay, so let's think it through, right? 5 squared is 25, right? What's 5 cubed? 125. Okay, so it's like 2's not quite big enough, right? And 3 is too big. Okay, actually that kind of tells us what our answer is going to be, right? We're not going to get pleasant whole number answers, and what do you think your answer is going to be between, since 2 is too small and 3 is too big? It's going to be like 2 point something. Okay, that's going to work here. Okay, so how do I solve when we can't do what we did a couple class times ago, which was get both bases the same, and then if the bases were the same, we said the exponents were the same. Okay, well, the answer is we're going to use the power of logarithms. So we're going to take either the natural log or the log of both sides. And then we're going to use the power rule of exponents, or sorry, of logarithms. So this is actually one of the most useful uses for logarithms out there, is when our unknown quantity happens to be in the exponent for a formula we're using. Then how do we come at the answer? And the answer to that is we use logarithms. So let me kind of show you how we can do that. So let's take this problem again. And then we're going to go through kind of some steps. Okay. So if I wanted to solve this, remember I said I can't write 66 as a power of 5 easily, right? So I'm going to do natural log. I'm going to take the natural log of both sides. So just to be clear, I'm not multiplying by ln. ln is not a number. ln is an operation. It's a thing you do, like multiplying, like dividing. Okay, so why would I want to take the log of both sides? Well, it's because the power rule now allows me to do what with this x? It allows me to move this around to the front, right? So it allows me to say, now I have x times ln of 5 equals ln of 66. So if my goal is to find out what x is, I actually am one step away from it now, right? If I want x isolated, what do I need to do? If I'm multiplying by something I'd rather not be there, what's the opposite of multiplication? Division, right? So I'm just going to divide by what I don't want on the left, but I can't do that without also doing what? The same thing to the right. Okay, in algebra we have to do the same thing to both sides. So then notice we end up getting x equals natural log of 66 divided by natural log of 5. Okay. So that is not a pleasant answer, but it is one that our calculator can give to us. So if we have a calculator out, we're going to do ln of 66, close the parentheses for that ln, right? And then we're going to divide it by what? ln of 5. Okay. And notice we get a really complicated decimal that is 2.6 blah, 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 right? So I'm just going to use the approximately equal to sign and say it's about 2.60. What did we already kind of guess the answer would be between? 2 and 3, right? And notice it is between 2 and 3, okay? So just kind of what we expected it to be. By the way, you can plug this in and check it. So we're going to try that here. So you can check by plugging in your answer. But just make sure that you understand that you're actually plugging in an approximate answer. So what does that mean about when you plug it in? Is it going to be perfect when you're plugging in an approximate answer? It's not, right? So let's try that and see if we can. So let's go back up to the original, right? So sorry, it's too blurry. Is 5 raised to the 2.30 power about 66? Okay, it was supposed to be 2.6, right? So, by the way, that tells me I did something wrong if what I got was 2.3, but that's not what I got, right? What was I supposed to get? 2.6, so let me change that. Okay, so notice, is it perfectly exactly 66? No, because why not? Because we were using a rounded answer, right? But it's pretty close, right? So I think we can argue that it's close enough, okay? We can know that it's correct. All right, let's try another one. So that was kind of, let's see, example 11. And let's say I wanted you to find x there. So let's do another one again where I ask you to find x. 7 to the 0.3x plus 1 power equals 813. Make sure that you write all of that 0.3x plus 1 as the exponent, like it's 7 to that blah, blah, blah power. Okay, so I'm just going to make a note here. Okay, notice that we can't write 813 as a power of 7 easily. Okay, so when we cannot do that, then what do we do to both sides? We take the log of both sides, right? This time I'm going to use log log just to show you that it actually doesn't matter which one you use. So I'm going to rewrite the problem and I'm just going to take the log of both sides. So just like adding the same thing to both sides, I'm allowed to take the log of both sides. Okay, by the way, what's the understood base again? 10. It doesn't really come into play here, to be honest, because we're just trying to use this power rule thing. Okay, so we're going to bring that whole thing around to the front. Just be careful when you do. Okay, it's actually 0.3x plus 1 in parentheses, and then times the log of 7 equals the log of 813. Notice I put that in parentheses because it's the whole exponent coming around to the front, and I want to group that and keep that together. So what am I trying to find / isolate? X is what I want to get all alone, right? So I just need to kind of do some things that get me X all alone. So the first thing I would probably do is go ahead and divide by the log of 7. Whatever you do to one side, what do you have to make sure you do again? Same thing to the other side, right? So notice that's gone, and now I just have 0.3x plus 1 equals the log of 813 over the log of 7, which is just a number. It's not a pleasant one, but it's a number our calculator can handle just fine. So now what if I want x all alone? Focus on the left side. Don't really care about what we have on the right side, right? We'll worry about that in a minute. So what do I get rid of next? The 1. So plus 1, I get rid of it by subtracting 1. Okay. So up here, I've got 0.3x equals the log of 813 divided by the log of 7 minus 1. So what's my final step then if I want x isolated? Yeah, divide by 0.3. So we may not love how this answer looks, but this is an answer that could be plugged into our calculator just the same as anything else. So we're just going to use our calculator to our advantage here. Make sure that you put anything with more than one piece in parentheses. Clearly this numerator is complicated, right? Definitely needs parentheses. So it's going to be log of 813 divided by log of 7 minus 1. And then I close the parentheses for that whole numerator, right? And then I divide the whole thing by what? 0.3. Not 0.03, but 0.3. And so notice I end up getting about 8.15 if you round it. Okay. Notice when I give you the answer, I'm asking you to circle the exact answer, which is the ugly thing, and then also the approximate answer. Okay. So we're almost out of time, but how would you check this if you wanted to? You would plug 8.15 back in here, okay, and see what you get. Okay. Just remember that you're not going to get perfectly the answer on the right-hand side because we didn't get a perfect answer here, right? We got something that was about 8.15. Okay, so it really doesn't make any difference which log you use. But we're going to do one more, squeeze in one more before the end of class. So I don't care what form of logarithm you use. However, I think in the case of this problem, there's clearly one log that is preferable over the other one. And what do you think? Which one is going to be preferable and why? Remember, E and what are partners? Natural log, right? So we don't want to use log log. We're going to use natural log. So in general, you can take whatever kind of logarithm you want of both sides. But when the problem involves E, use natural log. And let's talk about why we would. Okay. So we're still going to use power rule. This is still going to move where? To the front. But also we have something added here. Okay. So we have x times the natural log of E equals the natural log of 0.3059. However, we talked about this, right? What is the natural log of E? Because they're opposite operations. What do they do to each other essentially? They cancel each other out. In other words, the answer here is just 1. Okay, so you actually get rid of that. In other words, you don't have to divide by the natural log of E because you actually just get x equals the ln of that other side. And then we could just use our calculator to determine what that is, right? So we would do the natural log of 0.3509, and that gives us about negative 1.04 or 1.05. Make sure you round it. I don't think my math lab is going to ask you. Most of the time it asks you for the exact answers, but if it does ask you for the rounded answers, make sure you pay attention to how it tells you to round it. Okay. By the way, we can get negative answers. How come? We can't take logs of negatives, but we can get negative answers because remember the answers to logs are the what? The exponents, and the exponents can certainly be negative, right? So notice we're getting weird answers, okay? If we still wanted to, what could we do with this? We could check by plugging it in. Okay, just be aware that some problems are going to be closer than others when you check it to plug in. Okay, and the reason being, this is what I liken it to. If my bank makes a percentage error on my account, like say 10%, not that big of a deal because I'm a teacher and I don't make that much money. Okay, but if the numbers already are starting off to be larger, in other words, like this one. Notice if I'm 10% off or 5% off on a number like 8, it's not that big, right? But what if I'm 10 or 5% off on a number like 813? It means more, right? So just know that when you're checking your answers, if the numbers are quite large, your answers might be a little more off than they would be if the numbers were smaller, okay? But it should still be in the ballpark of what you expected, okay? Just not exact because we're rounding answers.